In this video, we are going to review equilibrium at a point. The objective will be solve for forces at a point in equilibrium. Recall the 5 steps to solve the problem. Step 1. Establish a coordinate system. Step 2. Determine which part of the body is to be studied and draw it out. Step 3. Draw the forces acting on the body. Step 4. Write and solve the governing equations, which will be the equilibrium equations. Step 5. Interpret the result. And now let's look at the problems that we're going to solve together. So a cable system carries a 500 Newton box with 3 cables joined at point Q. Find the tension in the 2 cables along the line AQ and BQ. Feel free to pause the video and solve it on your own. Here is the established coordinate system. So first method will be break the forces into components and solve using equilibrium equations. Q will be the part of body that we're going to study and draw it out. The first part will be the 500 Newton box that pulls it down. The second part will be the tension along BQ. And the last one will be the tension along AQ. Here is the equation of equilibrium that we want established in this problem. And now let's break the forces into X and Y components for both A and B. For the tension along AQ, the angle of incline will be 45 degrees, and for AX and AY, according to trigonometry, AX will equal to cosine 45 times the force, which we will call it A here. And AY equals to sine 45 times A. Now let's look at tension along BQ. The angle of incline will be 6 degrees here. According to trigonometry, we will get Bx for cosine 60 times the force, which we will call it B here, and for By will be sine 60 times the force B. Now we have enough information for the equilibrium equation. Ay is positive, so we will write sine 45 times A. And for By, it is also positive, so we will write sine 60 degrees times B. And for the box, it is going downward, which is negative. We will write negative 500 newtons. And for all the horizontal component, AX is pointing opposite side of the positive direction, which we will write it as negative cosine 45 times A. And for B is going positive, which we will write cosine 60 degrees times B. And now we're going to label these 2 equations as 1 and 2. Add them together, we will get sine 60 degrees times B plus cosine 60 degrees times B equals to 500 newtons. And solve for this equation, we'll get B equals to 366 newtons. And plug B into either equation 1 or 2, we will get A equals to 259 newtons. The second approach will be construct a fourth triangle and solve using sine-cosine law. Let's draw the fourth triangle together. The first part will be the 500 Newton box that's going downwards. The second part will be the tension along AQ, and it is at 45 degrees to the top left. The last one will be the tension along BQ. It is at an angle of 60 degrees and going to the top right. And now we can solve for the three angles of the triangle, which is 45 degrees, 30 degrees, and 105 degrees. Now let's recall what's sine and cosine law. Here are the formulas of them. And for this problem, we're going to use sine law. Input all the information that we have into this formula. And solve this equation. We will get B equals to 259 newtons and A equals to 366 newtons. So, in summary, here are the answers for this question. That's it for the video.